Welcome you all to the webinar series by IIT Alumni Center, Bangalore. So now the center has come up in Bangalore to take up the physical activities, and so this center is a unique networking platform to establish a collaboration between academia and industries, and importantly, the project of national importance can be taken up in this networking platform. So certainly IITACB plays a critical or the crucial role in establishing these projects among the interested members. So for today's webinar, we have two speakers, and today's speaker, Kartik Sawhney, is an entrepreneur, and he graduated from the Stanford in computer science. He has worked on several projects and initiatives to empower people with disabilities. And so he is a co-founder of I-Stem, where he leads technology and strategy. And for his work, he has been honored with many, many awards. And I'm just mentioning a few of them, which include Queen's Young's Leader Award, National Award for the Empowerment of Persons with Disabilities, which is the India's highest award for contribution to the disability sector, and the UN Young Leader Award. And along with Kartik, we have Nikhil Priyadarsh, who works with I-Stem, and he graduated recently from Indian Institute of Engineering, Science and Technology, Shirpur, and he has also worked on a lot of projects related to the accessibility and testing automation, document accessibility, remediation, and several other projects. So today's talk will be moderated by Dr. Jayaprakash, who is faculty in Indian Institute of Science, and he's working very closely to develop computational, theoretical, and experimental methods for obtaining real three-dimensional optical and optoacoustic imaging and multimodal imaging system. And so today's webinar will be co-hosted by Dr. Sushila Venkatraman and myself. And so for audience, please post your questions in Q&A box. And so this will be taken up during the discussion. We'll have short breaks between the talk. So over to Kartik for today's talk.
Thank you so much, Abha. Thank you for that very kind introduction. And so we're going to get started. Super excited about sharing what we are doing and sort of the broader connotations when you think about generative AI and accessibility with all of you. Would love for this to be pretty interactive. So again, as Abha mentioned, keep your questions coming and we'll get to those questions as we go. So again, real quick about I-Stem before we get started with what we're going to talk about today. I-Stem is really focused on trying to see how we can leverage technology to empower people with disabilities. That's sort of our core area, leveraging the latest in AI to try and do that. And so we've been working on a variety of products and initiatives focused around digital accessibility, focused around upskilling and hiring of people with disabilities, and technology has been at the center of all of this. So that's some context in terms of where we're coming from. Now, in terms of what we're going to be talking about today, really, it is starting out with Gen AI, what it really is. And again, I'm going to put this disclaimer out. We're no experts at Gen AI. It's a fast evolving sort of field. Our knowledge and our perspective on this is limited to how we've been leveraging it. And so we'll try to share that with you. But, would also love to get any feedback that some of you might have who are deep in research and maybe, looking at some of these aspects that we're going to be talking about in much more detail. But what we're really going to be talking about is how we are leveraging Gen AI for accessibility. So we'll be talking about digital accessibility. What are the opportunities here for Gen AI? What are the pitfalls as well that we should be aware of? When you think about using GPT or similar technology to help develop systems that can empower people with disabilities. And then we'll be talking about 3 specific case studies or products that we've been working on. We'll be talking about what we learned in the process and how they work. And then finally, we're going to get a little bit into evaluation, because how do you make sure that this can transition from an MVP, from a prototype, into something that can then be productionized. And so how do you start to think about some of those metrics and how we are thinking about it right now is something that we'll be talking about. So really, to get started in terms of what Gen AI is, I think many of the audience members who've been working in AI for a long time know that we've been talking a lot about like classification models and other kinds of things. Really try to understand and analyze. For example, in NLP, if you think about it, like unstructured data, unstructured comments, or trying to analyze images, et cetera, et cetera. But what really generative AI is, the subset that is focused on generation of content, and whether this content is language, this content is images, music, audio, what have you. How do you start to use AI to develop this concept is what Gen AI is. Has taken the world by storm, with things like ChatGPT that we'll just get to in a second, with things like Dolly for image generation, and a bunch of other stuff, as well. And it has, some key connotations and implications for people with disabilities in particular. So pretty exciting times to be in. And large language models in particular, which we are using quite a bit, is how do you start to think about generating language? And this is really focused on being able to identify patterns and probabilities in terms of what words come after other words, and really kind of training this at scale to be able to then be able to generate meaningful language. And so that's sort of what LLMs are about. I'm sure a lot of you in the audience already know this, but just for the sake of completeness, just wanted to mention this so we're all on the same page as we talk about specifically how accessibility relates to all of this. Now, GPT is from OpenAI. We've had GPT models from 1 to 4, each becoming better at being able to reason, understand, analyze, all of that kind of stuff. And so, just some understanding of, one possible sort of model that is available out there that's gained a lot of popularity from OpenAI. That's kind of what you use when you use ChatGPT. So we've been using that, GPT in particular a lot. Yeah. And then really thinking about how do you actually call GPT, how do you actually use GPT? And so a lot of it is through APIs, which is crazy, to think about. You can do some very complex things that you needed to train sort of custom models for only a couple of months ago, and now you're able to do all of that through a simple API, and then through sort of controlling various parameters that you're specifying through that API to determine whether you want it to be more factual, whether you want it to be more creative, whether you want it to be a balance of both factual and creative. And so you're able to then control a bunch of these factors using these parameters. And a lot of it really comes down to your prompts, which are basically ways in which you talk to the model, right? What do you want the model to do? Like, what exactly is the task? For example, you want to be able to generate code, and you provide certain specifics in terms of what exactly that code should be doing, what should be the functionality, if there are any constraints that the model should be accounting for. So things like that is something that you specify in prompts. And so it's really kind of saying, we're in this world where we're able to use natural language to be able to convey what we want the computer, the system to do, and it magically just happens. That's really what this comes down to. Now, of course, there are a lot of like nuances to this, but at a very high level, this is sort of what it is: to be able to give it a prompt, help it understand what you want it to do, provide it some parameters just to control the kind of response that you're hoping for, and then you get a response. That's at its core is what it looks like. Now, I wanted to shift gears a little bit because we're talking about sort of this intersection of, or its application of GPT or Gen AI more broadly to accessibility. So I wanted to take a second and just go through what accessibility really means. And accessibility is is essentially, how do you make systems better for people with disabilities? How do you make them inclusive so that anyone, irrespective of their ability, or is able to use these systems on an equal basis, and whether that means being able to navigate something through a keyboard alone because you cannot use a mouse, whether it means that for you to be able to kind of use a screen reader, which is what I use as a blind person, which essentially reads out everything on your computer screen to you in audio, whether it means you want to be able to access information in a simplified language because perhaps you have a learning disability. And so that is what accessibility is all about. Accessibility is all about trying to make things more accessible, more inclusive, so that it can be accessed by everyone, irrespective of who you are, irrespective of what your needs are, on an equal basis. That's kind of what this really comes down to. Now, I wanted to talk a little bit about some aspects of accessibility, just to give you a sense of what we're really talking about here. So one aspect, for example, is headings. Making sure that whenever you're designing a web page or developing a website, you do have proper headings so that someone who is blind, who might be listening to that using their screen reader, can navigate from one heading to the other. They can understand the structure of the page, because otherwise it can be a pretty sequential thing, where there's no way for them to know whether they can kind of navigate from one section to the other, because visually you can see these sections. You can see that there's something that is bolded, there's something that is in a larger font size, and you're able to then understand that and say, all right, I can jump through sections and only read the contents of the sections that I'm interested in. Now, if you don't have that, then it becomes pretty problematic. So one example, for example, for accessible development is this concept of headings, and making sure that you're using headings in your website, you're using the correct hierarchy, where the most important sections are heading level 1s, the subsections are heading level 2s, and so on and so forth, is something that you've got to be mindful of as you think through this, right? That's one example. The next example is around tables, making sure that you define table headers. Now, these are things where, let's say you have a pretty long table and someone is reading rows of a table, just listening to them. And so if you don't necessarily remind them what a specific column represented, they're going to struggle with that. And so how do you make sure that those headers are defined properly so that a screen reader can intelligently then read out, what column they're at, what is the header of that column, so that people can put everything into perspective and in context. That's kind of yet another example of accessibility, for example, that one needs to think about. The next one is link text. Now, oftentimes people who are using screen readers, again, software that read out everything on a computer screen, we like to navigate from link to link. We want to just get a structure of the link. Now, if you just name a link, click here, or something very arbitrary or random, it becomes difficult to understand what is the purpose of that link, right? So this is kind of another example of accessibility, where you're deliberately thinking about what that experience is going to be for someone using an assistive technology like a screen reader, who might be navigating this, as a list of links, for them to be able to understand, what's going on. And so providing that purpose as part of the link text is yet another example of trying to make something accessible. Similarly, I'm not going to go too much into it, labeled controls. This is making sure that when you have a form, for example, you're programmatically exposing the purpose of a form field to a screen reader or other assistive technologies. Now, what ends up happening oftentimes is when people don't develop thinking about accessibility, let's say I'm in an input field where I need to put in my first name, and then I need to go to an input field where I need to put in my last name. If you don't design it properly, a screen reader is going to read it as edit box. Now, I don't know what exactly am I supposed to fill in that edit box. Is it my email? Is it my first name? Is it my last name? Is it something else? And the worst case is, let's say you have a button, and that button is, and I'm making this up, delete everything on your computer, right? And now suddenly you don't know what the intended purpose of this button is if you've not labeled it correctly. It's going to read it as unlabeled button 0, and I'm now thinking, oh, maybe it means submit button, and then suddenly the next thing I know is my computer is wiped off. And so I'm kind of a little joking about this, but this has serious implications, right? I mean, if you don't have accessible financial institution websites, well, that can have catastrophic impact on what they can do to someone with a disability. And so that's kind of another example of why it's important to think about these things when you're trying to develop for design for accessibility. Similarly, captions for people who might be deaf or hard of hearing. If you don't provide them captions, that can be problematic. I mean, I can speak for myself as well as someone who's blind. I can't enjoy movies when you do not provide audio descriptions. Especially when there's this action movie that has a lot of things. I mean, you can probably ask your friends to describe, but how much are you going to ask them to do that, right? And so that's kind of another example where, if you don't have audio descriptions, if you don't have captions, yet another example of this is actually images, right? If you don't have images that are described for people who are blind, that a screen reader can pick up on, now suddenly you're excluding them from that information that is otherwise available to people who are sighted. So these are things that really come under the ambit of accessibility that you have to think through when you're designing it for everyone. Now, it might be sounding like it's pretty overwhelming, but honestly, a lot of this stuff is pretty basic, and it doesn't necessarily require you to know programming any different from what the kind of code that many of you might already be writing as software engineers, or as CS students, or what have you, right? It's really just being a little mindful of some of these things as you're developing. This is no rocket science. This doesn't require any specific specialized training or anything like that, right? But the problem is, unfortunately, this is not something that is often taught, and so that kind of becomes a little problematic. Now, unfortunately, over 96% of the web is inaccessible or has accessibility issues for people with disabilities, according to a recent survey, which should hopefully help you understand the gravity of the situation and why we really need to think about this seriously, so as not to exclude people with disabilities, which, by the way, that are, again, about 15% of the global population has disabilities. So that's the kind of audience we're talking about here. Now, the way we really think about this and test this today is we have some automated tools that can look at the code and run a couple of rules on top of it to say, okay, well, this is a violation and you've got to go and fix it. But then what ends up happening is most of it is still manual testing, where a person with a disability will basically just go and manually verify everything, or an accessibility professional will do that, and then provide a comprehensive report on what the violations are. And that's how we kind of, we kind of do this right now. Which again, it costs a lot of money, right? Like, if every single time, especially with agile development, whenever I'm shipping a new feature, like I really can't do that. It can be, having these audits like every 5 days or every 2 weeks or every month even, right? Like these are expensive. And so I think that the question now is, what do we do about that? And that's kind of where there are some opportunities that we have, particularly thanks to GPT, but also other advancements in AI. And we're going to be talking about a couple of these opportunities. Now, these opportunities that we're going to discuss are by no means exhaustive, but here are some opportunities that are already very promising. And so in particular, and I'll start off with the alt text example. Now, I was talking about how it can be pretty problematic for someone who is blind if you have an image on a page and that image is not described. Initially, this used to be a manual process. Even with object detection and segmentation models, this used to be one specific description, or you would basically just say, okay, the image contains A, B, and C objects. It was not really a comprehensive, a good description of the image. We actually now have this opportunity where we can enhance all of that thanks to generative AI models, both language and image, right? Where what we can do is we can have these models understand all of the context about the image, as well as also derive context from the surrounding text. So it now has a full understanding of what this this website is about, and within that context, what is this image trying to convey. It can use all of that information and then come up with a very holistic, comprehensive description for someone who is blind or low vision. So in some sense, you can automatically have images be described for people who can't see the images, something that wasn't possible before. Another thing here is verbosity. It can be possible that your description is very comprehensive, but I, as a blind user, I'm interested in one particular aspect of this image. And so how do I ask it specific questions about the image to try and understand and get the information that I am particularly interested in, right? And that's kind of, again, visual question answering has become something that a lot better with a lot of these models. And so there's a lot of promise there. Going to the next one, it's really this idea of discoverability. One of the biggest challenges that the disability community faces today is there's very little awareness about the rights of people with disabilities, about the services and resources that are available, and especially when you think about like majority of the population, the disabled population in India, for example, it becomes very challenging because they're not necessarily connected to these organizations working for people with disabilities, et cetera, et cetera. So how do you then make it possible for them to be able to get information without necessarily using a search engine, because many of them don't even have the digital literacy to be able to use a Google, for example. But today, you can create a chatbot that leverages information, let's say, for example, from the Ministry of Social Justice and Empowerment, that basically is able to provide them all of the information about the various schemes in the country, the rights that you have under the law, how you can procure assistive technologies, what schemes are available, et cetera, et cetera. All of that is possible today by essentially, we'll come to this in a second, by being able to develop systems that can retrieve information and then having sort of a model leverage this information to provide answers to users' question in whatever language that the user asks these questions. This can be in Hindi, this can be in Kannada, this can be in Telugu, whatever it is. So that is, again, something that wasn't possible before. Moving over to accessibility testing, I kind of talked about this a second ago, where a lot of the accessibility testing so far has been pretty manual, and this has been very challenging and super expensive. And so now we have an opportunity where we're able to leverage computer vision. We're able to leverage, these LLMs, large language models, to be able to automate a lot of that stuff. So for example, what I can say is, hey, can you check if all of the links on this web page have link text that adequately conveys the purpose of the link? And GPT can do that for me today. And if there are any violations, those can be flagged to a developer so that they can go and fix it now. Similarly, if something looks like a heading but has not been implemented as a heading, you can use computer vision models to catch that and report that as a potential violation. So there's a lot that can be done automatically now than what was possible. So that's kind of another very promising area where we can make sure that a lot of the software that ships is accessible and usable by people with disabilities. And then going to accessible code remediation. And this is kind of really talking about, okay, you've told me what the issues are. I don't know accessibility as a developer. I have other priorities as well. I just can't go and learn about accessibility. What option do you have for me? And this is kind of where, again, GPT can learn all about accessibility. It also understands all about the specific development framework that you might be using. For example, if you're using React, if you're using something else, can it basically put both of them together and then say, oh, actually, here is how you can go about fixing this issue. So this is kind of another sort of very promising area where not only can it alert you to potential violations, but it can also give you some guidance in terms of how do you actually go and remediate. Now, a lot of opportunities, when it comes to Gen AI and AI in particular, but also there are pitfalls. And I kind of wanted to talk about these as well, because it's not just a rosy picture. We've got to be extremely careful when using these models, because people with disabilities have been one of the most underrepresented communities. And so we don't want to marginalize them even inadvertently by misusing these models or potential misuse of these models. And so it's extremely important to be aware of some of these pitfalls. Starting out with biases. Now, as with any other AI model, this model is trained on data from the web, right? And large amounts of data from the web. Now, unfortunately, just given how our society is, there's a lot of bias around people with disabilities as well on the internet. And so how do we make sure that this model is not perpetuating these biases? What you see on the screen, hopefully, is an image of persons with disabilities that I asked Dolly to generate, and you can see, for it, people with disabilities are someone in a wheelchair, someone using crutches, and look at the faces, distorted faces, as if to say, oh, people with disabilities essentially means that there's a problem, right? And that couldn't be further from the truth as to how we as people with disabilities think about ourselves, right? And so it in some sense is perpetuating a lot of the bias around, oh, poor people with disabilities, they have problems, they need to be helped, that kind of stuff. And it's only limited to visible disabilities, the obvious ones, people in a wheelchair. You don't see anyone who any representation of someone who is neurodiverse here. You don't see anyone here who might have a kind of another disability, like even, for example, depression, right? And so that's kind of, again, something that we've got to be extremely careful about in terms of how are we representing, certain underrepresented and marginalized communities? Are we really doing justice? And it's the AI model doing justice. The second one kind of related to this is ableism. Now, ableism is essentially language and other expressions that can be derogatory or discriminatory to people with disabilities. Now, words like handicapped, we don't use that word in the community anymore. Right? I mean, that's considered disrespectful to people with disabilities. And you would see GPT sometimes use that. Now, that could potentially offend people. And so that's kind of another example. Now, other example is, and which is actually something that can have very dire consequences. When you ask GPT to write job descriptions, oftentimes it can come up with requirements that aren't really required. Asking people to have a driver's license when driving is not even a crucial part of the job. And now suddenly you're excluding a lot of people with disabilities who otherwise are competent and qualified to do the job, who wouldn't be able to apply because the model thinks that you need a driver's license, because for any job that requires travel, it's de facto and default is, oh, you'll be driving a car, and so you need a driver's license, which is not true. You could use alternate forms of transportation like Uber or Ola or what have you to basically get the job done as well. And so how do we make sure that you're being extremely careful about this and not inadvertently excluding people? Now, again, the next one is code generation. A lot of software engineers might relate to this. A lot of people are using copilots for automating a lot of their work, for generating a lot of their code, right? But again, as I said, over 96% of the web is inaccessible, which is to say that a large amount of code today is unfortunately inaccessible. And if an AI model is learning or is being trained on inaccessible code, then guess what kind of code it's going to generate? It's going to generate inaccessible code. And so that's kind of another risk that we have, which is how do we make sure that the code that it's generating, whether as part of GPT, as part of GitHub Copilot or Codex models, what have you, is in fact accessible? Because if we don't do that, then that 96% is probably going to become 99% 2 years later, because everyone would be using one of these copilots, and this copilot would essentially be generating inaccessible code for everyone, right? So that's kind of, again, another risk that we have. And so then is it kind of a gloomy picture? Like, is there nothing that we can do about it? Not really, right? I mean, I think there are two very important things that we can do to make sure that we're guarding ourselves against this. One, of course, is the training data itself, making sure that it's inclusive, making sure that you're not just getting training data from people without disabilities, but also specifically, deliberately getting it from people with disabilities. I'll give you an example. When I click a picture using my phone, that picture for sure is different from a picture when a sighted person clicks that picture, right? And so how do you make sure that my picture can also be used by a computer vision model just as good as how a sighted person's picture is going to be used for a computer vision model? So that's kind of and again, it also goes back to what I was describing above before in terms of representational harm, in terms of it representing people with disabilities only with wheelchair, et cetera, et cetera. How do you make sure that it's actually being trained on data that is more inclusive than that? The other thing, which is at the core of all of this, and not just related to Gen AI, but tech development in general, is this idea of co-creation. We have this saying in the disability community, nothing about us without us, right? Like involve us in everything that you do, in particular for anything that you do for us. We don't want it to be for people with disabilities. We want to be for and by people with disabilities, right? And so the thing to kind of be mindful here is how do you involve people with disabilities in the design phase, in the development phase, in the testing phase, the entire software development lifecycle, right? That's kind of important, and particularly important now with Gen AI and the potential pitfalls that I was talking about that it can have if not checked. So I'm going to stop here and I'm going to pass it over to Dr. Jaiprakash to see if we have any questions that we can take at this point in time based on what we've talked about.
Yeah, thanks a lot, Kartik. It was a very insightful talk. In the interest of time, we'll take the questions at the end. I would request Kartik to start, and we'll take all the questions at the end. Thank you.
Nikhil, over to you.
And Nikhil, yeah. Nikhil, please unmute yourself.
Hi, everyone. So now we will dive into three key areas that use GPT that are revolutionizing the way we interact with technology. So these three are retrieval augmented generation, or RAG, data collection, and task automation. So these are not just concepts, but these are practical tools that we have implemented and employed to drive innovation. So let's delve deeper into these technologies. So when working with ever-changing data, how do you adapt your LLMs to that data, to use that data? So there are two approaches. Either you fine-tune your model to adapt to that data, or you use the innovative retrieval augmented generation, or RAG. So fine-tuning, what it does is it adapts the base model to continuous domain changes by training it on the new data, and it improves the quality of the model, but it is often at higher cost. It requires more time and effort to train a model. So on the other hand, what RAG does is it allows real-time supplementation using prompt engineering. So RAG empowers businesses to leverage their existing models, providing a customized solution that maintains data relevance while optimizing costs. So it is very beneficial because it adds a fact-checking component to the existing model. Now, how does RAG go about this? So you have the data which is in your databases, and the cognitive search gets, based on the query from the user, the cognitive search gets the knowledge. So basically the most relevant data to the question asked by the user. Now, with that knowledge and along with the prompt designed by the developer, it calls GPT, and then GPT now factually answers this question. So increasing the factual accuracy of the answer that GPT gives, instead of just giving it the prompt, which would cause things like hallucination, where GPT could lie to you or come up with answers. Because it is a generative model, it could invent answers which are not factual. So how do you make your information factual? This RAG is an architecture which helps in that. Now I have a demo for RAG, how we have implemented RAG. So I'll just give you brief demo.
I just want to add, we do want to apologize for anyone who happens to be a person with a disability. Unfortunately, these videos are not accessible, but Nikhil will be talking through them as we go through them just to make sure that they're described as we go through them. Apologies about this.
Yeah. So RAG is able to answer users' questions accurately by first retrieving the answers, actual data, which is most relevant to the question, and then using that data as the reference for providing factual answer. So the user asked a question which was there in some document, so it fetched that document, and it generated the answer based on the information present in the document. So it didn't just generate that answer; it was able to check the factual accuracy as well. So there are answers in the document that are quite accurate to what the answer that GPT was able to generate. So similarly for other documents, it was able to find the data and then answer the questions accordingly. Now we go to our next tool, which is data collection. So data collection, traditionally, you basically have a set of questions that you ask the user to answer, but that is not an effective way of getting so the user may not understand the question, or it may be quite confusing. So user needs to understand what the question is about, ask the data collection tool to what exactly the question is. So now we have developed a tool which personalizes the data collection and accounts for user context and circumstances. So data collection now has evolved to become more personalized, accounting for user context, and an adaptive conversation takes place between the user and the data collection tool. So now by engaging the users based on their responses, we create a more fluid and intuitive experience. Now I'll show a demo of the data collection tool. So here's how the personalized data collection works. So as the user is interacting with the chatbot is adapting the conversation, and the chatbot is adapting the conversation based on the user's queries. Meanwhile, the focus of the conversation is always collection of feedback or collection of the data, which in this case is feedback, and the user wants to give feedback about Uber. Now the thing is, the question that has been asked from the user. Now user says that they because they are not very they don't have that much technical understanding, so they are saying that they won't be able to give technical feedback. So the chatbot understands that, and it so it says, no worries, even if it's not technical, it is valuable. You can share your experience in simple terms, focusing on what you find inaccessible. So it adapts to the conversation. Now you see the user says, tells the feedback, then the chatbot asks whether they want to rate it 1 or 1 to 5. If the user, so if the question is very long, then maybe someone with learning disability won't be able to read it, understand it quite well. So in that case, he or she can ask the user, the chatbot, that what the rating is about and how do you go on about rating it. So the chatbot helps in that as well. So this is another tool that we have, which is the data collection. And then finally, we have the task automation, which is a very fascinating tool uh, uh, that we have come up with. So task automation is not just about efficiency, it's about accessibility as well. So you want to connect GPT with workflows. So people with disability or people may find it difficult to interact with websites and apps that developers have built, and it may be quite challenging for them to suppose if you want to order something from a restaurant, you have to go through all the rest of, and it would be quite difficult to interact with all the interfaces that are present. So what if you were able to do that through a conversation? So GPT would be, you just chat with the chatbot and you tell it, I want to perform this task, and chatbot does it for you. You don't need any to go to the website and do something. You just say that to the chatbot, and it is able to execute that task for you. So we built a conversational agent which not only can interact with users via conversation, but it is able to execute their tasks by authorizing the user to the relevant app and then performing the required action on these apps on their behalf. So now I'll show a demo of the task automation, how task automation works. So this is a productivity scenario. So the user wants to check what messages they have on Discord. So they ask that question to the chatbot. The chatbot, in order to get the messages from Discord, it also needs to know certain things like from which server or which channel do you want to get the messages from. So it asks those questions in a conversation to the users. Now the user tells them that they want to read messages from this particular server, and now the chatbot is retrieving that information, and now you can see the chatbot has been able to get the latest message from Kartik, which is that he has sent an email about a meeting. Now the user wants to the user now sees that their latest message on Discord was informing that Kartik has sent an email. So now the user wants to read that latest email from Kartik. So the chatbot is able to fetch that by asking questions like whom they want to get the email from. So first the chatbot gets authentication from the user to actually access Gmail, and then finally it is able to fetch that email. So as it has said that I have retrieved the latest email from Kartik. Subject is meeting availability, and the email reads, it will be great to discuss task GPT, and he's available between 7 and 9. So now what the user wants to do is the user wants to schedule a meeting. So the tool needs access to the calendar of the user to see when they are free. So basically when the user authenticates the bot to access their calendar, now it has found out that the user is free at 8 p.m. So now they want to schedule that meeting at 8 p.m. So the chatbot, so they tell the chatbot that they want to schedule a meeting at 8 p.m. for 30 minutes, and and they want to send an invite to Kartik. So now the chatbot will schedule that meeting. Now it has scheduled that meeting. So now the user also wants to send a reply to Kartik saying that I have scheduled a meeting at this time at 8 p.m. So and to check their calendar for that. So chatbot asks what is the content that you want for the email. So user gives the content, or user can also say that create an email in this way, and the chatbot can do that for it. Now, once the content has been provided, user has sent that email. The chatbot has sent that email to Kartik now. Now, to verify that the chatbot has actually done, so I can I've shown that the meeting has been scheduled at 8 p.m. Now, the message that it fetched from Discord was accurate, and also an email has been sent to Kartik regarding the same. So all of the tasks that user had to perform, they only had to converse with the chatbot to do that. Now, okay, so what are the considerations that we need to have while implementing these solutions? What frameworks we want to use, what tools and technologies that we need to use. So some of these solutions include frameworks such as LangChain and vector databases, long-term memory, and as well as fine tuning of large language models. Uh, each plays a crucial role in developing seamless AI-powered applications. So what is LangChain? So LangChain provides a modular structure to work with large language models. So if you just go to GPT documentation or OpenAI documentation, it just tells you to you just call the API using using HTTP request, right? So, but that is a very basic solution which doesn't take into account several of the pitfalls that might occur. So what LangChain does is it helps in it is built on top of GPT and other large language models, and it helps in providing a framework which makes application development with the help of large language models possible. So you can implement include large language models into your application with the help of LangChain. So, uh, so it enhances applications that we have seen before, like the retrieval augmented generation system or the task automation, by offering solutions like data awareness. So it can connect your large language model to a data source that you have, or it provides agentivity, which is it allows large language models to interact with things like APIs, and it has chains tailored to specific use cases. So it is a very good tool to use while wanting to include large language models into your application. Then another thing is vector databases. Now the data that you have, the data that you get from your source might be very large, or it may so the present GPT models have limitations on the tokens. So you have 32K maximum, the token limit that GPT offers is 32K, and that model is also quite expensive. So what do you do to give data to GPT instead of from your data source if it is too large? So what vector databases provide a solution here is that they convert your data into vectors, high dimensional vectors, and those vectors can easily be used by AI model. So so when if any of you have been training any model, you would have seen that these models take vectors as input. So you can convert your documents and your data into vectors, and that can be used by the large language models. And also you can basically do that easily using embedded models, which convert these data into embedding vectors. So how do you use with GPT? It enables information retrieval or fact checking quite well and quite quickly, and it is able to access relevant and accurate information from the database. Now, another thing is long-term memory. So what is long-term memory? So if you have a very long conversation with GPT, you will start to observe that it starts forgetting things from the past. How do you keep a memory for GPT so that it does not and even if you keep a long conversation, it can exceed the token limit. So how do you solve this problem of a long-term memory for GPT? So long-term memory is a mechanism that allows GPT to remember information that is way beyond the immediate context, and it may be over a long context. So what are the solutions? One solution is summarization. So you can summarize the conversation into a few paragraphs or few words, so that GPT can use that. Or you could use embedding models to convert that conversation into an embedding to use it for future context. And finally, we have fine tuning, which is an expensive process, but it is also a very good process to adapt your model to specific tasks or domains. So fine tuning is it is the process of adapting a pre-trained model. So you have a model which already has been trained on a large amount of data, and you want to tune that model to your specific database, which suppose you have a model suppose you want to tune GPT to on data which is related to accessibility. So you want to, so the code generation model that you had previously, you want to make it so that it understands how to create accessible code. So what do? You give that data to GPT, and you fine tune the model based on that data. So now the model has both the information. Now it has adapted itself to the information, to the data source that you are using. So now it has become more adaptive to things like making accessible code. So now there are, while developing applications with large language models, here are certain key considerations that you need to keep in mind. So GPT and other large language models can go into hallucinations. So what is hallucination? The output that GPT gives may not be accurate. It can lie, or it can create answers that are quite not factual. It can create wrong answers. If you guys would have tried GPT to answer some complex questions like mathematical questions, it will come up with the answer, and if you give a test with it, it will probably fail because it is generating answers on its own because it is a generative model. So you need to keep design the prompt in a way that it does not create answers on its own. Then also another problem that we face as developers is that the GPT, how do you use the response of GPT, right? GPT gives a textual response. Now, as a developer, you need structured response in say a JSON format. Now, what might happen is GPT. So you say GPT that I want the date and time and something, and it may, or the date of birth of a person. So it may give date of your Python, your code may require it in, say, date _ birth key, but it may say DOB. Now your code cannot understand DOB, what DOB means, right? So you need to ensure how GPT gives a reliable response so that developers can actually use the response from GPT. So you use that using GPT functions. GPT functions are ways where you define to GPT how the function, what the function expects, and then GPT returns a JSON which basically gets the parameters that the function needs. And then finally we have prompt injection. So how do you make sure that the user, the data, so if you are interacting with GPT, you give it a prompt, right? So how do you make sure that the user's data is incorporated into the prompt safely, and GPT understands that is user data? So you need prompt engineering for that as well. You need to design your prompt in ways that it understands that what part of the prompt that it is getting contains the user data and is not just from the developer. So now finally, how do we evaluate GPT? So evaluating GPT models is important. And how do we evaluate it? We evaluate it using manual testing, using a representative test set. So you can create a test set which is representative, and then you ask questions on that test set, and you see how accurate the response is. But this is a manual process, so it requires a lot of effort. So you could use these tasks could also be performed by other models like ensemble models for PII removal. So you can use those models along with GPT to evaluate the performance of GPT. And finally, you could also use similarity scores with the sources. So to check how similar the answer given by GPT is with the actual source that it got the answer from. So to conclude, so generative AI has a lot of potential and in terms of accessibility, but it needs to be used responsibly to ensure that it works for everyone. So with this, now I would like to conclude this presentation, and I would like to hand it over to Dr. Jayaprakash to get the questions.
Yeah. Thanks a lot, Nikhil. So now let's go on to discussions and the Q&As. So I see there is one question here. So the question is to Karthik. The question is there anything that has been done for people who have been affected with stroke? Are you aware of any such work?
There has been a lot of assistive technology and research that has been developed specifically for that disability segment. Unfortunately, I can't remember specifics off the top of my head right now, but if they want to share that information, I'd be sure to share it with them. But yes, I have come across you know technological innovation that has been happening in that space quite a bit lately.
Yeah, sure. So as associated with, I have a question on the same on similar lines. So now, as you said, there is a lot of bias for people with disabilities because their data is not included in the models, so on, right? So now the question I had is, can these models be tailored for all these different kinds of disabilities?
Yeah, and that's
and is there some work in that space?
Yes, there is a lot of work happening to collect data specifically from people with disabilities. For example, there's a project that is focused on collecting atypical speech for people who might have atypical speech, right? So think about people who might have ALS and other things like that, right? And so there's a lot of work in collecting that. As I said, there's an Orbit data set available that is solely focused on collecting images from blind people. And so these images are are specifically from this community to make sure that any computer vision models aren't just good enough for good images that people who are sighted they take, but also this community. Similarly, there's a lot of work happening to collect data from other disability segments as well. And so I think the key thing again is twofold, like I mentioned. One being that this data collection process needs to continue, focusing on different disability segments for specific use cases, et cetera. But then the other one is, how do we ensure that more and more people with disabilities can be a part of this AI revolution themselves? Whether it's product managers, whether it's AI engineers, whether it's whatever it is. And so one of our key sort of considerations at I-Stem is we really focus on livelihoods, right? I mean, that's a very important sort of aspect of what all of our systems are about, right? How do you help people get into tech? And I think that is something that we really need to continue to push for. To ensure that people are involved at all levels and they're ensuring that their own needs are being accounted for when innovation is developed.
Yeah. So yeah, in order to allow that, right, I had a follow-up question. So now you spoke about standards and conformance for getting all these, getting everyone into that job market and so on, right? So are there any work that is done in the context of AI to bring standardization and conformance to allow all the applications to be disability friendly as well? So for example, the same thing comes in medical imaging as well, right? You have standards and so on. So, but there is very limited work where they focus on using AI to help standardization itself. So is there some work in that space?
Yes, that's a very good question. There is work as far as standardization goes for accessibility more broadly, right? So what constitutes a page being accessible? How do you make sure that it's accessible to all disabilities? How do you make sure that it does not just work for someone who is blind, but it also works for someone with a stroke, but it also works for someone with, dyslexia or dysgraphia, et cetera, So the W3C actually lays down what is known as the Web Content Accessibility Guidelines for that. Now, AI is something that is so new, but everyone in the industry, in the community, is talking about how it's extremely important that we include AI as a focus area and scope in WCAG or these accessibility guidelines as well. What does it mean? I think this is also a part of the broader discussion that we're having around regulation of AI, right? In terms of how do you make sure it's responsible, how do you make sure it's unbiased, how do you make sure it's safe, et cetera, and one part there is also how do you make sure that's inclusive and accessible to people with disabilities. Now, so far, no standards, but there's a lot of discussion in trying to do something about it. What makes it very tricky is just how these models in the first place work, right? I mean, in some
Mm.
sense, there's no determinism to them, right?
Correct.
And so how do you then even start to think about and say, well, okay, yes, if this is accessible, this is not accessible. And then also, how do you then factor in cultural sensitivities? Now, it might be completely all right for me in India to say that I am visually impaired or visually challenged.
Mm.
Such may not be the case in the United States. They
Yeah.
might take offense and say, well, oh, actually, you know what is visually impaired, visually challenged? We identify
Mm.
ourselves as blind. So
Mm.
there's so much complexity that comes in this, also because of intersectionality with a bunch of other attributes of who you are and your identity. All of that together makes it very complex. But nonetheless, I think it's important, and this is an active research area right now.
Yeah, fine. So I think there's another question in the chat. So as this from Ashok, he said, as ChatGPT been used to teach basic stuff with respect to IT BPO jobs to increase livelihood for disability, especially for persons with VI and persons with speech and hearing impairment.
So can you repeat what kinds of jobs again?
So it's basically IT BPO kind of jobs. That's
Yeah. This is very interesting. Part of
Mm.
what we're doing is actually doing that, right? I mean, upskilling is something that uh, particularly can benefit a lot from personalization. Nikhil was talking a lot about personalization, especially from data collection perspective, how it can adapt the conversation, et cetera, et cetera. Nothing better than that than upskilling.
Mm.
And so what we're doing as at I-Stem also is how can you teach, for example, a GPT non-visual pedagogy, and then can you have it teach, for example, computer programming, or
Mm.
have it teach other soft skills? Now, the beauty here is it is very good at piecing together stuff. So it understands non-visual pedagogy. It already understands, what software engineering entails, like, the basic, programming concepts. Can it now kind of use all of that information to provide this highly personalized experience to someone who is blind or low vision? But then also, can they adapt it as the student is going through that material?
Mm.
The student
Yeah.
says, I'm stuck. Is it able to then understand and then help them out? Kind of how Nikhil was showing in the data collection example, how when the person said, oh, I don't understand how the shading index works. Can you explain
Mm.
again, what exactly this is? It's exactly the same concept. And so you're able to provide highly personalized upskilling experiences that weren't possible. So to answer your question, yes. And that's kind of what we're actually actively exploring right now, and testing and piloting it out with people as well to try and establish the efficacy of such an intervention.
Yeah. So I had another question to Nikhil. So basically, you was talking about hallucinations and these different problems with these models, right? Are they people who have already quantified hallucinations? And what does we say hallucination, right? So is there a way to quantify whether the model is hallucinating or not? And are there any measures that has been defined for these?
Yeah, so one way to do this is you get the reliable source, you get the information from that, and then you match it with the answer that GPT is giving. So so I talked about similarity scores. So you can use those scores to find whether the answer that GPT is giving is actually factual or not. So in that case, you can actually that's why retrieval augmented generation is very crucial to the to solving this problem, because it gets the data from the data sources, and then it uses that data as well as the question given by the user to answer the question. So in that case, it can avoid these hallucinations, and it can avoid creating answers that are not present in the data. And this is a way to solve this problem.
Yeah, but is there any quantified metrics for that? Is it only the similarity score?
Yeah, you can use similarity scores.
Okay.
You can curate a data set which is which you can test it on, which you can test the GPT on, and
Yeah,
then
and just to clarify, similarity score is just a proxy.
Yeah.
To the best of our knowledge, there isn't anything specific developed per se to say whether it's hallucinating or not. But that's kind of a proxy to say, well, okay, and that also, of course, involves some thresholding, right? Like, what are you going to consider as similar? Are you saying 90% of it should be similar, 80% of that should be similar? And that is, again, something that requires experiments specific to the kind of domain you're talking about, the kind of data you're working with, right?
And also, to be highly accurate, you also need some manual testing to be done. So you need to have someone actually look at the answers that it is giving, and whether not only is it similar to the answers, but also it is not just you including the content from the data source, but it is also writing correct answers about it.
Yeah,
so
it's interesting. It's interesting that in AI in the industry always used to be, oh, here's the shipping criteria. I want the precision and recall to be 90% plus. That's how I would know that I'm going to ship it. No such thing anymore. There's no way for you to quantify. And so at best, you're really just talking about, okay, well, have I gotten enough feedback from my pilots that I, as a product owner, or I, as an AI engineer, feel comfortable in shipping this? And that's sort of how this is working right now.
Yeah, I have another question, which is basically, so now you're talking about, so if you want to have models include persons with disabilities, what you try to do is you try to include data coming from those sources as well, right? So did you already do this experiment of looking at the representation, okay, with the data excluded and with the data augmented with data coming from persons with disability, and is there any variations that you have observed clearly between the representations?
Yes and yes, and massive difference.
Okay.
I can give you an example. When you say, hey, I want to become a software engineer as a person with a disability, and you're asking like the vanilla foundational sort of models, like just ChatGPT, it's going to give you everything as is applicable for someone without a disability. It doesn't account for accommodations. It doesn't account for accessibility at all. It doesn't account for changes to the pathway that would be required for you to take as a person with a disability to be a successful software engineer. Now you train it with career experiences of software engineers with disabilities, and you now test it out. And it specifically, it certainly uses this information that it already has about software engineering as a career, but it then also factors in accommodations. It factors in accessibility. It factors in, okay, well, how do you get started with programming? It understands now that it's important for those courses to be accessible. Where do you find those accessible? It's important for IDEs or development environments to be accessible. All of those considerations that you really should be thinking about as a person with a disability, it is then able to consider all of that and provide you a more intelligent answer that is grounded in the disability experience.
Okay, yeah, interesting. And I also had another question. So now you have GPT-4, which has come up, right? So there they are trying to get multimodal data, that is text, images, and everything together. So now the thing is, can this framework be established where you are getting data from people having different disabilities, and that the holy grail kind of a model work for all kinds of people?
That's the goal. That's the goal. Because when we talk about accessibility in general, the idea is the person should be able to access it in a way that works for them. I think this goal was something that was considered several decades away. Now I think we're so close to that. You think about image to text, text to image. You think about text to speech, speech to text, everything in between. Now they're also talking about sign language generation and translation that has gotten such a boost because of this, right? So it's amazing in terms of what we can do with multimodal models. So very excited about that.
So, and another question I had is how to minimize the representational harms from this large language model.
And I think that goes back to, again, how do you develop more inclusive models, right? And that essentially the same thing. You've got to, I think one of the things is when you think about something like security, there's a lot of work happening to basically identify any potential vulnerabilities, et cetera, et cetera. We haven't done much of that when it comes to accessibility. Right? We haven't necessarily been like, okay, well, we've got to go and like really break this and kind of see, well, here are the issues. right? And then you can go and like address those issues in a in a systematic way, right? That is what needs to be done. When you do that, and of course, then the whole point around inclusive data collection, involving people who, this really concerns for their perspective, is something that is crucial as well.
Yeah. So yeah, in the area of medical imaging, the standard question is, how can you involve people who do not have access to healthcare? Right. So now the question here is, how can you involve people who are the most undeserving people? So without any internet connection, or
Exactly.
how is that happening?
And that's kind of also where now we have the chance that we didn't have before. So one of the areas is because it's all conversational. And if you think about task automation, Nikhil was sending emails, chatting with people on Discord, scheduling calendar invites, all of that using a conversation. Why couldn't we do the same thing on SMS and IVR? We could, right? And so now someone in rural India, somewhere in Karnataka, can basically just pull up their flip phone or the feature phone, not even a smartphone, no internet connectivity needed. Just send a message saying, this is what I want to do in their local language. And now they can get that information. Because now it's all conversation. It's actually linking that with actual actions that can be taken, right? So that's actually very promising. Something that we're actively, as with us that are really focused on that segment when it comes to scale. We're very excited about the potential of reaching that 60% people with disabilities in the country that we just never had access to before. So yeah, a lot of potential.
Yeah, and also I have another question, which is, so there's a lot of discussion regarding AI here, right? AI, deep learning, and so on. Are there any augmented methods, for example, something like haptics or instrumentations, along with AI, so that it helps much more? Because I know that there is a conference called CHI and so on, where there's a lot of people who are working on these kind of aspects. They're working on human-computer interaction and haptics and these kind of technologies, along with AI. So how far has this gone in
critical, right? A standard example, you as a blind person are trying to navigate a place, right? One way to basically do this is go left, go right, go left, go right, go straight, go left, go right. So overwhelming, right? You think about cognitive overload, can't get worse when you are trying to listen to the traffic around you as well to be able to cross a street properly and safely. How do you then use alternate means, whether it's haptic, whether it's 3D audio, whether it's something else, to basically be able to provide you information in a way that's actually much more manageable? There's a whole consortium that is also looking into making VR, XR, all of that kind of stuff more accessible. I think it's called Access XR, etc. I'm not very sure of the exact name, but there's a lot of work happening around that with companies like Meta and others, really Apple, thinking about how do you make this immersive. And by the way, this is, we've been talking about very serious stuff around livelihoods and transportation. I mean, even recreation, right? Like everyone can play games and play these Xboxes and PlayStations and whatnot, and I can't. There's also a lot of work happening there. Like when you're talking about immersive experiences for others when it comes to recreation, how do you also provide people with disabilities the same experiences for recreation as well? So I think there's a lot of potential. Certainly not tapped all that much yet, but it's good to see that especially the top tech companies are actively understanding the gaps here and trying to fill in some of those gaps.
Okay, so how do you see the differences, right? For example, if you think about geographically, right? So the developments which is happening in the different developed countries versus the developing countries. So how do you see the technological access and so on? Or what is your comment on this?
And it's very interesting you asked that, because you would think that everything is kind of taken care of when you think about things in the US. And it couldn't be further from the truth. They have their own issues. I think what helps a little bit there is just the laws are actually pretty strict. And so, if I wanted to go and say, hey, this food delivery app is not working, you better go and fix it, like I'll sue them and they've got to do it, right? And that's just That's just a right that I have. That's a little bit of an issue, but also there, we're trying to work with the government. The disability division in MSJ has been extremely forthcoming. We have something that is a chief commissioner for persons with disabilities in India that's actually now being pretty forceful, and when it comes to service providers, say, hey, I need to report in the next 60 days. What have you done? Right? So it's actually very promising. On the other hand, I think we in India have a lot of the opportunity that they in the West just absolutely don't, right? You think about what we can do in terms of, again, as I said, conversations for conversational experiences that essentially would convert the entire web into conversations. You could never have the sort of impact you would have with that in India anywhere else. Right. So I think in some sense, we're really fortunate that we actually have pretty crazy problems that can have amazing, massive impact. The kinds of opportunities we in particular have here that they don't have. Having said that, I think, we just need more people to be talking about disability and accessibility here, right? There's already a lot of stuff happening. I think more people need to talk about that. More investment needs to flow into that, into research, and into development, to make sure that we're really being inclusive. But overall, I mean, I think there's great opportunity and great promise all around.
Yeah. So Nikhil, I had one question regarding this fine tuning part. So you are talking about fine tuning and these aspects, right? So did you include the data with and without accessibility and see whether the fine tuning time was more or less, or it was similar?
Yeah, so this is something that we are currently working on. So we are actually getting in the process of collecting data, which includes people, includes data from people with disability, and we are trying to develop models that are that include that information and that are tuned to that data to be able. And GPT also provides ways to tune its own model, which is through your own data. So that is also possible with large language models.
Yeah. Just for some quick context there, so far we've been using RAG for pretty much everything, just given it's lower and it's cheaper, but also our use cases have largely been around, hey, yes, you can find the relevant information and then you can leverage that information. Where we can't do that is where you need a very deep understanding of a certain concept. Right? For example, if you want to write accessible code, it's not enough to pull out the right part of the standard and say, okay, well, I'm going to use it. You have to necessarily have all of the requirements together simultaneously, right? To be able to say, okay, now I'm an expert at this, I'm a master at this, and now I can basically go and do that, which is why and where fine tuning comes in. And so that's sort of the stage we're at, where it's a lot about like, now the whole, the whole stuff around search is not going to work anymore. We need a model that is much more intelligent and has like a nuanced understanding and a deep understanding of this very specific thing that we wanted to leverage. So
and a lot of it depends on the collection of that data as well. So coordinating with authorities who can and other organizations who can actually provide that data to us, who can so that, because tuning always requires a lot amount of data, and it needs that data. So we are currently working towards that as well.
Okay. So what is the, in your entire development pipeline, right? What is the biggest bottleneck you're facing?
I think fine tuning data is definitely a big one.
Data,
in the community, we call it a data desert. We don't have enough data. But then also the thing is that the problem is disability is a very personalized and a very individualistic experience. I am no one to say that my views and my perspective is the perspective of every blind person on this planet. Right. And so then how do you actually have a large sample that would make any sense and be meaningful? That's sort of our biggest sort of challenge right now.
Yeah, and during data collection also, right? I understand that it's very difficult to convince people to get the data, get good data from, right? So that's also a very big issue.
And then how do you do that ethically too?
Ethically, that is
you compensate them or whatever you do, right? Like that's kind of the other aspect.
Yeah. And are there any governmental support for these kind of things?
So we've
For
had
developing these?
yeah, we've had the Accessible India campaign that the Prime Minister
Hmm.
launched several years ago.
Hmm.
We also have some funding earmarked and more funding coming out from various ministries, some from the Ministry of Health, some from MSJE.
Hmm.
The
Great.
Ministry of MIT basically actually did an innovation challenge to
Hmm.
enhance web accessibility automated test coverage last year. So it's very it is happening.
Hmm.
RBI actually did a hackathon recently, which was focused on more inclusive banking for people with disabilities.
Hmm.
So different departments are and different ministries are doing it. I think we just need more. We just need more of that.
Yeah.
You
Yeah.
know, there's so many problems to solve.
Yeah.
But yeah.
And there is one question here. So, yeah. So there is a question of what is the relevance of braille in the current context of screen readers?
Yeah, very good question. I think it's very relevant, and it's actually very relevant, particularly for kids, because you know, if you don't have a spatial understanding of how things look, then it can be very problematic. The other thing is, you know, even things like spelling, right?
Hmm.
If you're not actually reading the spelling, so what happens with a screen reader is actually it actually reads word by word, or you know, you're not gonna list, you're not gonna stop it and like you know read character by character usually. But then if you don't do that, then how do you teach someone spelling, right?
Yeah.
How do you teach someone things like geometry, for example?
Hmm.
You know, and other spatial things like that. So I think it's very relevant. It's actually a little unfortunate that a lot of the special quote unquote schools have moved a little away from Braille
Hmm.
to this. But in my view, it's you know, both are important and both have their own place. So
Okay. Fine. Yeah. So we had a exhaustive discussion. Are there any further questions from the audience? Okay. So if not, I will hand it over to Dr. Shushila Venkatram for closing. Thanks a lot, Kartik. Thanks,
thank you so
for a
much.
wonderful talk.
Thank you.
Thank you, sir.
Thank you all very much. This has been a very interesting discussion about an area that is clearly a very high priority, and an area that we don't very often give much thought to. When Kartik said that 96% of all the material on the web is inaccessible, whereas 15% of the global population has a disability. Obviously, we must be giving much more attention, paying much more attention to this matter, and should be looking at how to address this. Today, we delved into large language models and how they are being used to bring in inclusiveness for all. We basically talked about the accessibility of all data, irrespective of what an individual's specific needs might be. And we are today able to take a view about this and discuss this and say that it is possible to do it only because of the existence of the tools that we are seeing in AI today. And while we all see jokes every day about ChatGPT and what it does, clearly what I-Stem has done is to harness the power of that technology to do a lot of good for the segment of people with disabilities. We started with a few definitions, and Kartik, thank you very much for that, because I think it was important to bring everyone on a common understanding of many of these issues many of these terms that a lot of people do not really fully understand. And we looked at what elements must be thought about when these models are built from the point of view of accessibility, and a few aspects with things like headings, column headers, descriptive links, captioning, etc. And I think when a lot of us, when we now look at a lot of the audience, when we consider designing a system, we'll certainly look at these things in a different light than we've thought about them so far. We looked at accessibility testing, which is obviously essential if you're going to talk about inclusion. But what we understood today was that emerging AI tools are making it possible to do testing much better, much faster, and in a much more robust fashion than we used to do in the past. In addition to test results, these tools are also providing remediation recommendations. So obviously, that is a very powerful addition to the testing tools. We looked at information discoverability as well, and what is required to, and a few ideas around what is required to address that issue. We went on to look at pitfalls and how they can be avoided or mitigated, and pitfalls such as biases, ableism, and inaccessible code generation. And two ways of mitigating many of these pitfalls include data that pertains to disabilities while training the model. So you're already including data of different kinds while training the model. And the other very significant point that Kartik made was co-creation with the community. This is not about doing something for a segment of people, but it is by them, for themselves. So it's important to make sure that we look at these models using the whole paradigm of co-creation. Nikhil then went on to share specifics and went into details of the technology. And thank you, Nikhil, for that, because I'm sure many of our audience would have appreciated what is required to do something like this. And he went on to demonstrate 3 specific cases and how they've been realized. We saw frameworks for making application development of large language models more robust, and specifically looked at LangChain, vector databases, and long-term memory. And then we looked at some key considerations for developers and how they can avoid situations such as, or rather address, mitigate hallucination, how to use, and very importantly, how do you use the responses that have been churned out by the LLMs? It's very well to joke about them, but it's equally important for us to appreciate that the responses given by the LLMs need to be taken in a certain context. We had a lot of discussion thereafter, and thank you, Dr. Jayaprakash, for bringing up many of those important issues. We discussed, talked about how people with disabilities can participate in the building of applications that are more inclusive. Now, we looked at standards, and we also got to understand that this is very complex as these models are non-deterministic. And also, we need to account for things like cultural sensitivities, etc., which is really not the easiest thing to do when you're looking at a completely new world. So welcome to this new world that we are in now, and it's going to be very interesting seeing how things evolve over the next couple of years, for sure, as we try to grapple with many of these ethical issues and issues around inclusiveness and cultural issues and so on. So thank you very much for this presentation today. It was, and this whole topic of GPT has been long on our radar, and we're very thankful that Kartik and Nikhil, you presented to us today, and Dr. Jayaprakash for stepping in and moderating the session today. To our audience, thank you for participating and your questions, and we will see you in our next webinar. Thank you very much.